Hello students. Now in this video let's see our third function of number theory, that will be the Mobius function. Now let's see the definition of it. Definition: a Mobius function is a function mu from z plus to complex number, defined as mu of n is equal to 1 if n equal to 1, minus 1 raised to k if n equal to p1, p2, so on up to what pk. 0 if p square divides n. So using this definition, let's see some examples. What about mu of 2? Now 2 is a prime number, but the prime factorization of 2 can be written as 2 equal to 2 only one prime number is this. So the second definition will be followed here. So it will be minus 1 raised to what? 1. K will be 1. So here it is nothing but minus 1. Mu of 3 is it, so what? Minus 1 raised to 1. So it will be minus 1. Again, mu of 4. Mu of 4 is what? 0. Why does this? Since 2 square divides what? 4. P square divides n. Fine. Next, what about mu of 5? Mu of 5. 5 is again a prime, so it is minus 1 raised to 1, so minus 1. What about mu of 6? Mu of 6 is what? Minus 1 raised to how much? 2. Why does this? Since 6 is equal to 2 into 3. So 2 prime numbers are there. How many prime numbers are there? That was the power here. So it is what? 1. Then what about mu of 7? Mu of 7 is how much? Minus 1 raised to 1. So it is minus 1. Mu of 8. Mu of 8 is how much? 0. Why does this? Since 2 square divides what? 8 also. Mu of 9. What about mu of 9? Mu of 9 is also 0. Why does this? Because 3 square divides what? 9. Mu of 10. What is mu of 10? It is 10 is equal to how much? 2 into 5. So minus 1 raised to what? 2. So it will be 1. Then mu of 50. Mu of 50 is how much? 0. Why does this? Since 5 square divides what? 50. Next, mu of 80. Mu of 80 is also what? 0. Why does this? Because 2 square divides 80. Then next, mu of 100 equal to 0. Because 5 square divides 100 as such. So from these we can write the remark. Suppose let me write 2 remarks. Remark 1. From these, if you observe, look at here. This 2 is a prime number. Its Mobius function having value minus 1. 3 is a prime Mobius function having value minus 1. 5 is a prime having value minus 1. 7 is a prime having value minus 1. Other are not prime. Well, these are prime. So what can we say? Remark 1. If P is prime, then mu of P is equal to what? Minus 1. Then second remark, you can say if P is perfect square, then Look at here. 4 is a perfect square number, so it is 0. Then 9 is a perfect square number, it is 0. 100 is a perfect square number, so its Mobius function is what? 0. If p is a prime, then, or if not p, we will say n. Let's say n. N is a perfect square, then mu of n is equal to what? 0. So these are the remarks from these questions we can see. Now let's see some theorems on this Mobius function. So theorem, the Mobius function mu is multiplicative. Okay, so proof. Let Mn belongs to what? Z, plus such that M and N are relatively prime. Claim is that mu of Mn is equal to mu of M into mu of N. Okay? If M equal to N equal to 1, then Mn is how much? 1. If Mn is 1, then look at here, what is the mu of M? Mu of M is also 1 from definition, fine. And mu of N is also what? 1 there. Also, mu of Mn is also what? M, because product will be 1, fine. So, if M and N are same or they are 1, then this multiplicative rule will follow. So, mu of Mn is equal to mu of M into mu of N in that case, fine. Now, the question is left for M and N are not 1. So, if they are not 1, we can write them as a prime factorization. So, if M is equal to, suppose, P1, P2, so on up to what? PR, and N equal to, suppose, Q1, Q2, so on up to what? Qk. Therefore, mu of M, what is mu of M? Mu of M is nothing but minus 1 raised to R, and mu of N is equal to minus 1 raised to K. Therefore, what about mu of Mn? Mu of M into mu of N, that will be minus 1 raised to R into minus 1 raised to K, and that is nothing but minus 1 raised to R plus K. Also Mn is equal to P1, P2, so on up to what? PR, Q1, Q2, so on up to what? Qk. Therefore, mu of Mn is equal to minus 1 raised to R plus K. That is same as mu of M into mu of N. So, here if M and N are the prime factorization, then also this valid. Now the question is left for what? If M and N are divisor of any prime square number. So if either the third possibility from the definition of Mobius function, for one we had checked, for prime factorization we had checked. Now the question is left for if either p square divides m or p square divides n. This gives p square divides mn. Therefore, mu of mn is equal to what? 0, and that is same as mu of m into mu of n. Okay. Thus Mobius function Thus Mobius function mu is multiplicative function, is multiplicative function, is multiplicative function. Okay, so in all cases from the definition of Mobius function we had checked that Mobius function is multiplicative function. Now let's go for the next theorem. Now the next theorem says that for any positive integer, n in z plus, summation mu of d where d divides n is equal to 1 if n is equal to 1 and 0 if n is greater than 1. Now proof. Let n belongs to z plus, then consider capital F of n, that will be summation mu of d where d divides n. As mu is multiplicative, Fn is also multiplicative. Fn is also multiplicative. If n equal to 1, then f of 1 is equal to summation mu of d where d divides what? 1, and that is nothing but that is equivalent to what? Mu of 1, and it will be 1. Fine. Now let n is equal to n is greater than 1, then by fundamental theorem of factorization, theorem of factorization, n is equal to p1 raised to alpha 1, p2 raised to alpha 2, and so on up to pr raised to alpha r. That is equal to product p raised to alpha of what? P. Fine. Now from this what we get? This Fn is, it will be product of whom? F of p raised to alpha over p. Fine. Call it as equation number 1. Now what is f of p raised to alpha? Let's find it. F of p raised to alpha is nothing but summation mu of d where d divides p raised to whom? Alpha. Fine. That is same as mu of 1 plus mu of p plus mu of p square plus so on up to mu of p raised to whom? Alpha. That is equal to mu of 1 is 1, mu of p is what? Minus 1, p is a prime. Mu of p square is what? 0. Obviously mu of p cube is what? 0, and so on up to what? 0. Why does this? Since p square divides p square divides p cube, and so on. p square will divides all those further terms. So there becomes 0. So 1 and minus 1, so that will become 0. Therefore we get f of p raised to alpha is how much? 0. Fine. Now using this, what does 1 becomes? Equation 1 gives fn is what? Product of this 0 over p, so that will be what? 0. Thus what we get? Thus we get summation mu of d, where d divides n, is what? It will be 1 if n is what? 1, and it will be 0. It will be 0 if n is what? Greater than 1. N will be greater than 1. This is about the theorem. Now we have to see further a Mobius inversion formula. Next theorem, that is Mobius inversion formula. So what does it say? Let n be any positive integer and if fn is equal to summation f of d, where d divides n, then this fn is equal to summation d divides n mu of d and capital F of n upon d. This is a Mobius inversion formula. Now let's see the proof of this. Let n is any positive integer. Consider this one. Let's consider this part. Summation, we will come up to this one. Fine. Let's see this. This is given to us. Fine. Summation mu of d into capital F of n upon d. D divides on n. That is same as summation d divides n. This mu of d as it is. Here this f of n upon d, we can use this definition here. So here we can say this is summation c divides n upon d. N upon d is a number, it will play a role of n now, into f of c, suppose. Here c, okay, f of c. That is same as summation d divides n into, this summation we can take before, summation c divides n upon d mu of d into f of c. Okay. Now note that d divides n and c divides n upon d. If and only if c divides on n, and if and only if, let me write here, c divides n and d divides n upon c. This is using the properties of divisibility. We can write this. Fine. So if this is this one, this part will become, let me call it as equation star. Therefore star implies summation d divides n mu of d capital F of n upon d, that is equal to this summation will become summation, this d divides n will be replaced by c divides n. Okay, and this another summation, here this divide, this will replace by this one. Summation d divides n upon c into mu of d into f of c. Okay, so this is same as summation c divides n f of c into summation d divides n upon c mu of d. Okay, now mu of d, but we can say here this n upon c is equal to 1, summation mu of d where d divides n upon c is what? It is 0 or it is 1 if n upon c is equal to 1, that is n equal to what? C, and it is 0 if n upon c greater than 1, that is n greater than whom? C. Here that is n equal to what? C. This is using the previous theorem. So here now if we assume if n equal to c, therefore summation mu of d into capital F of n upon d divides n, that will be summation, here n equal to c f of c into summation d divides 1 mu of d. Okay, so it will be what? F of n. Here c will be what? C is how much? N. So here it will become f of n, and this part will become what? 1. So f of 1 into 1, f of n into 1, that is same as f of n. As such we can prove this. This part should be noted here. This is using simply the properties of divisibility. Okay, now next part we have to take one example here. Now example, evaluate summation mu of n factorial n from 1 to infinity. So solution, here summation mu of n factorial n from 1 to infinity, that is equal to what? Mu of 1 factorial plus mu of 2 factorial plus mu of 3 factorial plus so on up to mu of n factorial. So 1 factorial is equal to 1, 2 factorial is equal to 2, 3 factorial is equal to 1 into 2 into 3, 4 factorial is equal to 1 into 2 into 3 into what? 4. 5 factorial is equal to 1 into 2 into 3 into 4 into 5. This is known to you. For further explanation I need to write at least this one, and so on you can say. Okay. In general, what you will observe here, in general, if n greater equal 4, then n factorial is equal to 1 into 2 into 3 into 4 into so on up to what? N. So from this what can we say? 4 divides whom? N factorial, that is 2 square divides n factorial. This is for all n greater equal what? 4. If a prime square divides that one, therefore we can say mu of n factorial will be what? 0 for all n greater equal what? 4. Also, what about mu of 1 factorial? Mu of 1 factorial is how much? Mu of 1. That will be 1. Mu of 2 factorial is equal to what? Mu of 2. That is equal to how much? -1. Already we have seen it. Mu of 3 factorial, so it is mu of 6. That will be 1. And further part will become 0. Okay. Therefore, summation mu of n factorial, n goes from 1 to infinity, equal to how much? 1 plus -1 plus 1 plus 0 plus 0 plus so on up to how much? These are all what? 0. So here what we get? Therefore, or here no need to this one. Here these one will become 0. Here what we get? Therefore, summation n from 1 to infinity of mu of n factorial is how much? 1. This is about this example. Now, from this example, let's write one note. Mu of n factorial is equal to what? 1. Sorry, summation, not n factorial, it is summation n from 1 to infinity mu of n factorial is equal to 1. This is first one, suppose. And second, what about summation n from 0 to infinity of mu of n factorial? So this is, you can say, mu of 0 factorial plus summation mu of n factorial n from 1 to infinity. So 0 factorial is 1, so mu of 1 is how much? 1. And this one, you know, it is 1. So it is how much? It will be 2. This is how much? 2 here. Fine. Now, one more example we have to take. This note is, you should remember. Now, example. For every n belongs to set of positive integer, show that mu of n plus 1, mu of n plus 2, mu of n plus 3 is what? 0. Solution. Let n is a positive integer, then by division algorithm n is equal to what? 4q plus r, where 0 less equal r less than what? 4. Why we take 4 here? Because it is up to n plus 3. 4 numbers are there. 4 continuous or 4 consecutive integers are there. n plus 1, n plus 2, n plus 3 as such. Okay. That is, n is equal to 4q or 4q plus 1 or 4q plus 2 or 4q plus 3. If n equal to 4q, then 4 divides n, that is 2 square divides n. So this gives mu of n is equal to what? 0. Therefore, this product will become 0. Mu of n plus 1, mu of n plus 2, mu of n plus 3 is what? 0. Now next, if n is equal to 4q plus 1, then what about n plus 3? n plus 3 is 4 into q plus 1, n plus 3. So it will be this. So this gives 4 divides n plus 3. That is same as 2 square divides n plus 3. Therefore, mu of n plus 3 is what? 0. Therefore, from this mu of n plus 1, mu of n plus 2, mu of n plus 3 are what? 0. Then next, if n is equal to 4q plus 2, then n plus 2. n plus 2 is 4 into q plus 1 again. So this is again 4 divides n plus 2. So that will be 2 square divides n plus 2. Therefore, mu of n plus 2 is equal to what? 0. Therefore, mu of n plus 1, mu of n plus 2, mu of n plus 3 is what? 0. Next, if n is equal to 4q plus 3, then n plus 1 is equal to 4 into q plus 1. So that will be 4 divides n plus 1. So that is 2 square divides n plus 1. Therefore, mu of n plus 1 is what? 0. Therefore, again mu of n plus 1, mu of n plus 2 and mu of n plus 3 are what? 0. So, in all cases for 4 consecutive integers we get this product will become 0. So, this is all about the third chapter. In third chapter we have seen 3 different functions, not only 3, while in second one there are many functions, but togetherly they are known as arithmetic functions. So first one greatest integer function, second one arithmetic function, and the third one Mobius function. So in next video we will see the next chapter, that is quadratic reciprocity. Thank you.